Hi aspirants, welcome back to our channel AgriVision for you. So with the release of GATE 2025 application form, let us concurrent with AgriVision for you's comprehensive series. In this series, we will tackle past questions and its master concepts. So stay updated with our channel, and also you can enroll in our GATE XCXL 2025 batch using my code, that is AgriG50, for flat 50% discount. And yes, don't miss our curated videos for GATE XC 2024 and 2023. You can find them in our playlist for a head start on your preparation. So let's get started. Question number 1. Which among the given option truly depicts the line 1 and 2 in the figure below with respect to the effect of heat processings on food? Options are quality, safety and quality, yield or safety, yield quality, or quality or safety. So basically, in thermal processing, it is defined as a combination of temperature and time which is required to eliminate a desired number of microorganisms from a given food product. Now, the types of heat processings can be like pasteurization, blanching, sterilization, retorting, drying, microwave sterilization, and so on. So over here, my line 1, it is about, means as the process severity it increases, the safety of the food generally it will increase. So this is because higher temperature can kill the microorganisms. So basically my line 1 is about the safety. Next, while the higher temperature can increase the safety, they can also degrade the quality attributes like the flavor, textures, or the aromas, colors of the food product. So this is because excessive heat can lead to the overcooking and degradation of these properties. So therefore, my first line it depicts the safety, and the second line it depicts the quality. So over here my correct option will be option number A. Question number 2. Homogenization of milk leads to disintegration of fat globules by, options are turbulence and pasteurization, pasteurization and cavitation, pasteurization and pressurization, or turbulence and cavitation. So basically the process of breaking up of fat globules to a very small size in order to prevent the cream formation, it is known as homogenization. Now, it is most likely that a combination of these two theories, that is turbulence as well as the cavitation, it explains the reduction in the size of the fat globules during the homogenization process. So what is turbulence? Basically, it is the energy which is dissipating in the liquid going through the homogenizer valve. It generates intense turbulent eddies of the same size as the average globule diameter. Now the globules are thus torn apart by these eddy current, hence it reduces their average size. Whereas cavitation, it is considerably the pressure drop with change of the velocity of the fluid. Say the liquid cavities, because of its vapor pressure is attained, the cavitations it generates further eddies that would produce disruptions of the fat globules, and this high velocity it will give the liquid a high kinetic energy which is disrupted in a very short period of time. So increased pressure increases the velocity. Now dissipation of this energy, it will lead to a high energy density. So energy per volume and time, which will result in the diameter, which is a function of the energy density. So over here my correct answer will be option number D, that is turbulence and cavitation. Okay, question number 3. The lowest water activity supporting the growth of Staphylococcus aureus in food under aerobic condition is. So options are 0.98, 0.91, 0.89 or 0.86. So a characteristic feature that distinguishes the Staphylococcus aureus from other pathogenic bacteria is its high tolerance of low water activity. It is high tolerance and the NaCl concentrations up to 20%, as well as now generally it is reported that minimal water activity for the Staphylococcus growth, it is in the range of 0.83 to 0.86. So over here the most accurate answer will be option number D. That is, the correct option is D, that is 0.86. But those values, it is dependent on the pH, temperature, humectants, we can say, humectants, atmospheric conditions. So with respect to the enterotoxins production requirement, values of water activity for their productions are mostly in the same range as for the growth of the producer. And in food with decrease in water activity at the aerobic conditions, these enterotoxins can be produced even in the value ranges from 0.86 to 0.89. But over here my most correct answer will be option number D. Question number 4. Cultures which are used in the industrial production of yogurts are Lactococcus, Lactis subspecies Lactis, Streptococcus thermophilus, Leuconostoc mesenteroides subspecies Cremoris, Lactobacillus delbrueckii subspecies Bulgaricus. So this yogurt actually it is a popular fermented dairy product which is produced by the lactic acid bacteria. These are Streptococcus thermophilus and Lactobacillus delbrueckii subspecies Bulgaricus. So during the yogurt production, these bacteria they produces the lactic acid, decreases the pH, which can cause the proteins to coagulate. So over here my correct option will be option number B and option number D. Number 5. In a dairy plant, spray drying technology is used to produce the whey powder. The rate of spray drying it depends on options are temperature of the incoming air, shape of the cyclone separator, diameter of the whey droplets, or the heat transfer coefficient of the hot air. So basically the temperature of the incoming air, as the higher the temperature, air can accelerate the drying process by increasing the rate of evaporations. So this option number A it is correct. So it depends on the temperature of the incoming air. Now the shape of a cyclone separator, uh, diameter of the shape of the cyclone separator. Okay. So the shape of the cyclone separator can influence the efficiency of the separation process, but it doesn't directly affect the rate of drying. So this option will not be correct. Next, diameter of the whey droplet. So as explained, smaller droplets have a larger surface area to volume ratio, so it will lead to faster evaporation. So this option will also be correct. Next, heat transfer coefficient of hot air. So as the higher heat transfer coefficient, actually it means the hot air can transfer heat more efficiently to the droplets. Now this will speed up the drying process. Therefore, uh, this option is also correct. So over here my correct option will be A, C and D. Next question number 6. The parboiling of paddy results into increase in the milling losses, increase in the nutritional value of rice, increase in the head rice recovery, or increase in the broken rice percentage. Okay, first what is parboiling? So parboiling, it is a hydrothermal treatment. It is a hydrothermal treatment in which the paddy it is soaked in water and steamed to obtain a gelatinized rice. Now this parboiling it seals any crack within the rice which can cause the rice to become harder and results in higher milling yield and less breakage. So higher milling yield, not losses. This option is wrong. And increase in the and less breakage. So this option is also incorrect. Now during parboiling, some water soluble nutrients they move from the bran of the rice kernel into the starchy endosperms. So this minimizes some of the nutrient losses. So that means there will be increase in the nutritional value. That happens normally it happens during the refining when making it white rice. So especially it is rich in we can say vitamin B, vitamin B such as riboflavins, niacins, vitamin B6. So it will also increase in the head rice recovery since it will make the rice a bit harder. So option number B and option number C will be correct option. Question number 7. 100 kg paddy is dried from 18% wet basis to 13% wet basis moisture content. The amount of water removed in kg from the paddy is how much? We have to calculate and round it off to one decimal place. So let's write first what are the things given. Initial weight, it is given initial weight 100 kg, initial moisture content that is 18% weight basis, final moisture content that is 13% weight basis. Now first we have to calculate the final weight after drying. So final weight after drying, final weight after drying. So let this be WF, final weight after drying. So what is the formula? Initial weight into 100 minus initial moisture content divided by 100 minus final moisture content. So let's calculate it. What is the initial weight? That is 100 into 100 minus initial moisture content that is 18 by 100 minus final moisture content that is 13. So it will be 100 into 82 by 87. So you will get it approx 94.25 kg. Now the amount of water that is removed, amount of water 100 minus this final weight that is 94.25. So it is approx 5.75 kg. So this is your answer. Now question number 8. The radius of centrifugal bowl is 0.1. So radius it is 0.1 meter or we can say 10 centimeter. And it is rotating at 850 revolution per minute. So RPM it is 850. The centrifugal force developed in the gravity force G, we have to calculate the centrifugal force that is RCF. It is equal to, so we know 11.18 into the radius that is R into RPM by 100 square. So it will be 11.18 into radius is 10. RPM is 850 by 100, or it is 80.92 kg. So the answer will be 80.92 kg. In the canning industry, the total process time F0 was calculated as 3 minutes. If each can contains 20 spores having a decimal reduction time of 1.6 minutes, the probability of spoilage would be how much in 100 cans? So F, it is given 3 minutes, D is given 1.6 minutes. So we know a formula, that is N naught equal to 10 to the power F by D. And this formula, it came from log N naught minus log N equal to F by D. We will keep log N1, we'll get this. So, okay, over here, we'll put the value F3 by 1.6. So, we'll get an approx of 74.98. So, initially there were 74.98 spores, we can say. Now, probability of spoilage. So probability of spoilage, it is calculated as the spores which is left in the cans divided by the initial number of spores. So probability of spoilage calculated as spores which is left in can, spores left in can divided by the initial number of spores. Initial number of spores. 20 divided by 74.98. So I'm writing here. So 20 divided by 74.98, it will be 0.2667 in one can. Okay, that means for 100 cans it will be, for 100 cans it will be calculated as 0.2667 into 100, that will be 26.66. So over here my correct answer will be 26.66. Question number 10. Match the edible oil refining stages. So this edible oil refining stage, it is an important part for this GATE examination. So you should know this part. You should never leave this topic. So it is given in column 1 with their respective functions in column 2. So first one is degumming. So degumming, actually it is a process which involves removing the phospholipids, that is gums, from the oil. So it matches with P3. Next, neutralization. So neutralization, actually this step, it involves the free fatty acids which is present in the oil and cause rancidity. So it matches with Q4. Bleaching. So bleaching, actually this process, it removes the pigment and other impurities from the oil. Hence it improves the color of the oil. So R2. So winterization, it is the process of separation of waxes. Actually it involves chilling the oil to remove the waxes, other impurities that can cause the cloud to the oil at low temperature. So my correct option will be 3, that is P3Q4R2S1. 11. Make the correct pair of food packaging technology given in column 1 with the operation principles or descriptions in column 2. So column 1, that is aseptic packaging. Actually, this involves the sterilizing both the food and the packaging material separately before filling the package under a sterile condition. So P, it is actually independent sterilization of food packaging material and the packaging under the sterile environment. Number 3. Next, active packaging. So active packaging actually this is a type of packaging which interacts with the product or the environment to extend its shelf life or improve the quality. So it can release or absorb the gases, maintain humidity, or even it can act as a sensors. So active packaging, it best suits as a non-passive contributions to the product development. Next, modified atmospheric packaging, that is MAP. So this involves altering the atmosphere. So as the name is saying, it alters the atmosphere inside the package to create an environment that is more suitable for the product. So this often involves controlling the oxygen levels and carbon dioxide levels. So it matches with one, that is control of the concentration of oxygen and carbon dioxide inside the package. So R1. And vacuum packaging. So vacuum packaging, this involves removing most of the air from the package to prevent oxidation and the microbial growth. That means it creates a tight package wall. S. So the correct option will be P3Q4R1S2. Option number A will be my correct option. So in this video, we have completed the first 11 questions of GATE XC 2022. The second part will be updated soon. So stay tuned. Till then, thank you and enjoy learning.